Okay, so 40A here, show that this is false, right? When you got three lines here, this saying it's identical. It's identical for any value theta and phi, right? So if you can find one value of theta and phi where this doesn't work, then you found a counterexample. So then this statement isn't true, okay? Because three lines means true for every value of theta and phi. So all you need is one example where it doesn't work. So suppose I set theta, I don't know, I'm just having a go. So suppose I set theta to equals 30. Phi to equals 60. Okay, so let's see what that is. Now on the left hand side, okay, I will have sine. So theta's left hand side here, obviously theta's 30, phi is 60. So that'll be then sine 90, won't it? And I know sine 90 is equal to 1, right? I know that. We can use a calculator. And then right hand side, sine theta then is 30. Plus then sine phi, right? Oh, one more over sine phi. Well, phi is 60, isn't it? So I should put 60 there. Good. Well, if I type that into my calculator, sine 30 plus sine 60, well, you got that. That doesn't come out as 1, right? So it's 1.366 in there, okay? So you could say, look, left-hand side is not equals to right-hand side, okay, when theta is 30, phi is 60, therefore statement false. That is all you need to do. The other thing you could do as well, you know, if you're not sure about these values, or if it actually worked, right? Because you sometimes pick values and it works, right? And you think, well, what am I meant to do here? You've got to try two other values. You could try something silly. You could put theta to equal 1 and phi to equal 2, you know, so the silly values, or theta to equal 1.5, theta to equal 7, right? It doesn't matter as long as you find an example where it doesn't work. Okay, so part B then, you've got here part B. So, you know, again, we're going to have this sort of quadratic thing coming up. It's got to come up somewhere. So we've got this here. So we've got, if you notice here, sec theta, okay, is the linear one. That we can't change that one. So we need to change tan squared, right? We need to get this in terms of sec squared, right? That's important because you can't change this. So get everything in terms of sec. So again, you know, if you go back to the principles from C2, that idea there. Now this time I'm going to divide by cos squared. Okay, and I'll get the other result. Sine over cos is tan, so that's tan squared theta. That's going to be 1, and 1 over cos is sec, so that's sec squared theta. So straight away now I can get tan squared theta to equal sec squared theta minus 1. Alright, so if I chuck it into that top formula, I'll have sec squared theta plus 8 equals 4. Now tan squared theta is this, sec squared theta minus 1, plus then 5 sec theta. Okay, then multiply out, so sec squared theta plus 8 equals 4 sec squared theta minus 4 plus 5 sec theta. Okay, simplify it, get everything to one side, so 3 sec squared theta plus 5 sec theta, and then take that 8 over minus 12 equals 0. Alright, so we got a quadratic, we need to solve this, put 3 sec theta in both brackets, multiply, add, so 3 times 12 is minus 30, 3 times minus 12 is minus 36, add up to give 5, two numbers to give 36, that's 9 and 4, okay, and we get 5, it needs to be minus 4, and then they multiply to give minus 36, so we can do that. Divide them by 3 to pay back. First bracket there, it's got a factor of 3, so you can take that out there. Second bracket hasn't got any factor. 3's cancel, so then you've got this situation there where this is equal to 0. So then you've got then the sec theta plus 3 equals 0, or the 3 sec theta minus 4 equals to 0. So sec theta equals to minus 3, sec theta equals to 4/3. Now you can't solve it in terms of sec. You need to solve it in terms of cos, because sec, remember, is 1 over cos. So 1 over cos, well, you could write that as cos then if you do the reciprocal. So that'll be minus 1/3, or cos then theta here, the reciprocal of this is 3/4. So you've got two situations there. We're going to find now the answers to these. We'll use the calculator to find one solution, then we use the graph, and we're finally there. So theta then is 109.5 there. or in this case then you've got 3/4. That comes out to be 41.4. Right, so we're going to draw the graph. So every 2 to represent 90. Now we don't need anything negative in this case because everything came out as positive in our results. 90, 180, 270, 360. So your cos graph looks like this. 1 here, -1. So if we take the results then, -1/3, which is about here, isn't it? Draw a line at -1/3. So you've got the two results then. But this result there, which is 109.5, which is the one that was given. And to get the other result there, okay, with cos, you just do 360 minus. Look at the symmetry there, you're going back from 360. 9.5, so you get your two answers. So take that away, 250 point something, 5, and then the other one then, 41.4 is at 3/4, so we're up here. Again with the cos, so you've got your theta then is 41.4, the other one then will be 360 minus it. So this is 300 and what is it, 318.6. Use your calculator, of course. We've got those two answers, two sets of answers there, and you're done.